At ESPN.com, we service literally tens of thousands of requests per second. Let me say that number again, 10,000 plus requests a second. In 1 second, over 10,000 requests come in, and it's not like 1 second goes by and then a minute later we get another 10,000 plus requests. It's relentless. Every second for hours during events, we get 10,000 plus requests a second. The way we scale to that number, or the way we did scale to that number, is a heavy reliance on web page caching. That's critical for us. That doesn't work so great for personalized content. All right, how much data are we talking about? A gig, 2 gigs? No, that's the next part of the problem. We need to store over 10 million users. We have more than 10 million users, but as far as personalized folks, we need to plan for 10 million plus. On average, each of these users takes about 5 kilobytes of data. Some a little bit more, 100K, 200K, some less, but on average, we're looking at about 5K. With full redundancy, if you do the math out, we need to handle or store 200 gigabytes of data. That's certainly not going to fit into 1 JVM, or 2, or even 100. Let's make things more complicated for good measure. On top of all this, we need to leverage this same personalization system for our mobile websites, for soccernet.com, and for deportes.com. The whole point of personalization is not just about personalization, it's also similar to single sign-on. When you tell us what your favorite team is, when you go to ESPN.com, we want that same preference to carry forward on our iPhone Score Center device, on your BlackBerry device, on any device you have, and other websites we own, such as soccernet.com and deportes.com. So how did we do it? This is the fun part. I couldn't wait for this part. So I'm going to describe how we built this quickly, and this is a lot of fun here. So it all starts with a relational database like any other enterprise-grade system. Ours is called the Personalization DB. We weren't very creative with the name. Then we introduced 2 new exotic components, the grid, which you've been waiting for, and the composer. The grid is using IBM WebSphere eXtreme scale. It's effectively an in-memory representation of everything in that personalization DB. The key to this is it's extremely fast. We're talking sub-millisecond response time. The composer is the next part of the equation. The composer facades the complexity in dealing with our existing services. But let me take a quick step back. When a lot of people think of ESPN.com, you might think of 1, 2, maybe 3 services for ESPN.com. That's not the case at all. We literally have hundreds of back-end systems powering our website. The composer brings them all together. It facades the complexity of dealing with all our services, and it knows how to speak with a grid. So let's see it in action. A user request comes in, or in our case, thousands and thousands come in at the same time. They queue up on the composer, and the composer knows how to talk to the grid. It goes to the grid and gets your preferences. Again, lightning fast, sub-millisecond response time. The composer now knows, based on your preferences, which of our services to go to. So for example, if you're an MLB fan, we'll go to the MLB service. If you're an NFL fan, we'll go to that. And we'll go to multiple services if we need to. From that, the composer is intelligent enough to build a response back for you, the fan, and you get your personalized content. Now the key point here is from the moment a user request comes in to the moment it goes out, we're in single-digit millisecond response time. It's extremely fast, and that's why it scales the way it scales. So how does it scale? Fast. The grid is based on 10 physical servers. These are commodity servers. These aren't mainframe multi-million-dollar boxes. These are pretty commodity servers. There's 10 of them. Each have 32 gigs of RAM. We chose to use 20 of those 32 gigs of RAM for a grand total of our 200 gigs. We're using eXtreme scale to power the grid. We loaded 12 million users into this system, and we had 40% room to grow. We're utilizing a few really cool features of eXtreme scale that actually compress the size of these objects so we get more bang for the buck. We threw 12,000 requests a second, and then we threw 15,000 requests a second at the grid. And here's the best part. Not only did it handle it, CPU on all 10 of the servers stayed below 5% the entire time. We never go above 5%. And this is an interesting feature here. So we obviously overbuilt a little bit. Another really cool feature of the grid is you can dynamically, at runtime, so our service is running, we can spin down servers and we can spin up servers if we need to. So if we underestimate it, if we need another 10 servers, we can jump to 20 servers right away. If, on the other hand, as in our case, we have 10 servers and we only need, say, 5 or 6, we can drop the other 5 or 6 at runtime. And on top of that, we have full redundancy. Any one of our servers can go offline at any time, and we don't skip a beat. The grid automatically repartitions everything and puts data where it needs to go. So how long did it take to do this? 1, 2 years? 3 months from inception to production. I'm not making this up. It actually took longer for me to get this through our legal team at ESPN to buy the software than it did to actually build, test, and deploy it.